plus b. The only formulas you will need to remember for the beginning is, remember, point slope form that you can then solve into y equals mx plus b. And then your slope formula, you may need to know that. The only formulas they will give you for this exam are going to be the exponential application ones. And really, they only give you the compound interest ones, compounded continuously and compounded the other types. Okay. Do we feel the need to go over solving equations, writing equations of lines in the first four? Anyone feel the need for those right now? Those should be generally kind of easy, I would think. Plus, it's multiple choice. So remember, you can always double check your answers that way. Remember, perpendicular means use the opposite reciprocal slope. Parallel, use the same slope, that type of thing. Usually we forget how to do stuff like 5 and 6. Find the domain. We did do those. Remember, when you have something like 5, what kind of numbers can you not divide by in fractions? 0. So you can't have 0 on the bottom. Remember also, when you do stuff like 5, you can't have what kind of numbers that you can square root? You can't square root negative numbers, right? So the way we found the domain on this one is that we set what was underneath the square root as greater than or equal to 0, or is it just greater than 0 in this case? You can't divide by 0. And in this case, you can't square root a negative, so you're just going to do greater than 0 there. If I solve that, it's a very easy solving. I get x is greater than what? 4. That means x can be 4 and numbers larger, which means out to where? Infinity, because remember that's how we write domains, with parentheses. You will have a calculator on that, so if all else fails on those, graph them and see what they look like. So let me just grab my calculator on that one. I can show you what I mean by that. On your calculator graph, you can always graph what that looks like to see. So you would have 12x plus 3, and then the square root of x minus 4. And if you can't see it, remember we zoom out to see what that looks like. Did I get that in there, or did something happen here? No, I'm good. All right, then I'm just going to do my zoom out to see what it looks like. There it is. So that doesn't always give you like 100% idea of what the number starts at, but it would certainly give you a good idea for, like, in a multiple choice question, you could have that to this as an answer. You could have that as an answer. You could have this as an answer. You could have that as an answer. So it should help you like eliminate some of those. We know the first one is negative infinity up to 2, just skips 2 and goes out to infinity. Well, clearly I don't have another half over here, right? So that couldn't be my answer. This one is from negative infinity up to 4. Well, we clearly don't have anything in the left side of the graph there. The other way to tell on your calculator where that's getting really close to is to check out your table. So if I go into my table, I get errors. So look at my x's here. All the negative x's, I'm getting error, error, error. Go along. I have undefined at 4, which is still bad. But then at 5, it's okay. That doesn't mean start at 5. It means 4 is bad, but it's probably pretty close to 4. That's why there's the parentheses in 4 and then goes out to infinity. So the table should help you with that. It's always good to know how to solve those. 6 is easier because 6 on that review, that one is simply a rational function. Remember, you just can't have 0 on the bottom. So how do you figure out the values that give you 0 on the bottom for that one? Take the bottom and factor. What factors of negative 18 add up to 3? Positive 6, negative 3, which tells me that the values of negative 6 and 3 are the ones that would give me 0 on the bottom. So remember, how do you leave those out of a domain if I can't use negative 6 and 3? I go from negative infinity along to where? Negative 6. I skip over negative 6 and go on to where? 3. I skip over 3 and keep going to infinity. Okay. That I feel like is more common than the other one. But remember, there's only 30 questions on this. You can't really get to a whole lot there. The next section is the function composition, which we always forget that too. Remember, this notation means the same thing as f of g of x. Do we remember what to do in those cases? Or no? F of g of x means take your f of x function, take out its x, and in place of x, put your g of x function. All you have to do then is combine like terms. So for f of g of x, what would be my final answer? X squared minus 2x plus what? 5. G of f of x is the opposite. So in this case, I would take which function to start with? The g of x function, which has 2 x's in it. And in place of its x's, what would I put? The f of x function. This one you'd actually have to FOIL. FOIL the x plus 2 times x plus 2. And then combine like terms. Okay. Describe the transformation on 9 and 10 should be easy. If they have a plus 6 in the parentheses, which way is it moving it? Left 6, right? Because remember, in the parentheses is the opposite. The second one gives you the parent function. This is a quadratic. Once you know it's a parent function of a quadratic, which way has it been moved here and here? If it's right 2 up 3, right? I's. Usually we're pretty good at 11. FOIL that out. Remember, I squared is the same as what? Negative 1. We don't typically remember how to do 12. Complex conjugates. That's where we multiply by the bottom, but change the sign in the middle. Top and bottom. And then FOIL out both. Do you need me to finish that, or do you feel like once you have that, that's okay? Yes, no, maybe. Yeah. To finish that out, you would FOIL the top there. That would give me negative 12 minus 30i plus 14i plus 35i squared, which will change in a minute. On the bottom, I would get 4 plus 10i minus 10i minus 25i squared. Both of my I squareds will change to negative 1, making this negative 35 and this positive 25. So my final answer here would be negative 47 minus 16i. And then these two cancel on the bottom, so on the bottom I would have 29. If that reduced, I would reduce, but it doesn't, so you don't have to. All right. Anything else up to that point? After that comes a bunch of solving for x stuff. That can be anything from basic solving for x's to quadratic formula to factoring. Like question 13 does not factor, so I would use quadratic formula. 14 factors, 15 should be kind of easy. 16, I think, factors. If it doesn't use quadratic formula, do we feel like we have to go through 13 through 20? I do want to do 20. I just looked at that one. And also, always remember, if there's a certain question that I've chosen to go over, it may or may not be because I remember it being somewhere, aka question 20. I feel like that question is very often missed. When we have ones like that on 20, we have a square root of x and we have an x as well. We typically don't remember how to solve those types. Those are the ones where we move the square root term to the other side and then square both sides. So what I have when I move that to the other side is this. The other issue with these is because of the square root, you always have to check your answers. And that's what people don't do. They can usually get through the solving, but this checking the answers is what we forget. When I square both sides, what do I have to do on the left here? When I have to square the 4x plus 7, I have to FOIL. Okay, so fully FOIL the right side, or the left side. On the right, when I square that, I'm squaring the 2, which gives me what? 4, and I'm squaring the square root of x, which just gives me x. Now this is still a quadratic, which means I'm still going to have to move everything to one side and factor. So right now I have 16x squared, 28 and 28 gives me 56. But then I'm subtracting the 4, so it's actually 52x plus 49. I would try to factor this first. Always remember, though, if you can't figure out your factors, you are on a calculator test, you can always graph the quadratic and find the x-intercepts. So if you can't solve something, always go for that. That's always your best way. But factoring is usually pretty quick and easy for these. Where would you start for factoring with this? 16x squared, your starting factors should be what? 4x and 4x. And your starting factors for 49 should be what? 7 and 7. In this case, is that actually going to work? No. Because that's going to go right back to what I had on the left side without the 4x. So if it can't be, well, what other options do I have for 49? Other than 7 and 7? None. Other than 49 and 1, which is extremely unlikely. So I would not change that. I would go back to your 4x and 4x. What other options do I have for that? 8 and 2. This is going to give me 56x. Yikes. 56 and 14. Is that going to give me my 52? No. Okay. Do you think we're actually going to get there? Probably not. So my options for that one would then be to go and check in my calculator. So I don't feel like this is going to factor nicely. At that point, I really wouldn't go to quadratic formula if I have a calculator. I'd go to graphing. So if I were you, I'm going to get rid of my table here. And I'm going to go back to my normal graph, just clear everything out here, and I'm going to graph my equation. 16x squared plus 52x plus 49. Now, you can kind of see that. All right. The fact that my quadratic is up there means what about any x-intercepts? There are none. What does that mean about this equation? There's no solution to it. That's what happens sometimes, okay? And that's okay. This one has imaginary solutions written down. It's lovely. If you need to get those, that's where you do quadratic formula. So if it says no real solutions on your multiple choice form, you can do that. In this case, it has the imaginary answers written down. Just a quick review of that. I will write that out. I don't remember that being a problem, but just quadratic formula on that. Do you need me to go through that or no? Okay. That's the same question. It's written on the answer key as imaginary answers, but you would just set up your quadratic formula for that. That would work out to imaginary answers. Most of us can simplify that quite nicely. I'm not real worried about that part of it. Solving inequalities, 21, 22, 23. Any great need for that? 22? Sure. When you have absolute value, remember for absolute value, when you drop the bars, what does that do to the answers? Whoops, scrolled too far. What does the absolute value do to the answer when you drop the bars? Yep, makes them positive and negative, and because it's an inequality, that means I'm going to have 3x minus 4 is less than or equal to 8, and when I change the sign of the answer for the other one, I also change the inequality sign. Remember, when you multiply or divide by a negative, you switch your inequality sign. It works the same way with switching the sign of the answer here. So I've got 3x is less than or equal to 12, so x is less than or equal to 4. And then I have 3x is greater than or equal to negative 4, so x is greater than or equal to negative 4 over 3. And then you would graph it if they asked you to, but I don't believe that they did in this case. They just have x is between negative 4 over 3, because you can write your answer in this form. Because it's less than 4 and greater than negative 4/3, it's in between the two of them in the answer form. 20 what? 21. Yep. When it's in between like that, that just means when you solve those, I'll write it up here for you. You just have to do everything to all three sides, really. It's like there's three sides of the equation. So your goal is to get x by itself in the middle. So you have to subtract 3 from all three parts. And then when you're still solving for x, you're going to divide everything by 3. So my final answer there would be negative 1/3 x 5/3. So x is between negative 1/3 and 5/3. Just a note on 24 and 25, how their answers look. When we did end behavior, we did based off of degree and leading coefficient. So 24 is an even degree with a negative leading coefficient. Which way do the ends go? Down. You're going to see the answer for 24 says Q3 and 4. That means quadrant 3 and 4. That's their way of saying both ends are going into those quadrants, the lower quadrants. 25, when you have end behavior for odd positive, the left side goes down, the right side goes up. You're going to see their answer says quadrant 1 and 3. That's because the right side goes up into quadrant 1, the left side goes down into quadrant 3. It's just notation. 26, 27, find the real zeros. You can factor. You can also graph that and just find your x-intercepts. If they have answers in square root form and you get your x-intercepts off of your graph, remember you can always type those square roots into your calculator to get the equivalent decimal. But I think a lot of those factor. Real zeros. Then this stuff, the rest of this we've done pretty recently. Like 28 and 29, those are both synthetic division questions. Okay? Do you need me to go over synthetic division? Yeah? 20, well, either one, I'll just set up both maybe. 28, what you have to be careful of is to remember that there's the missing cubed term there. So when you set up 28, you want to set it up with the -2 outside. And then inside, you want 6 followed by the 0. Some people were missing that on the test that we were doing with this. So don't forget your missing terms there. If you need hope for your dual credit exam, I remember there being a synthetic division question on there. That should be easy. So go through your synthetic division process. Once you get to your answer on this one, remember that, goodness, this is a fun one, 92. Your remainder is the last one, constant x squared, x cubed is how you write your answer. So I would do 6x cubed minus 12x squared plus 26x minus 46 plus a remainder. And you write your remainder over what you were dividing by to begin with. So my answer would look like this. You can do synthetic division with 29. What number would you put outside the box on 29? 1/4. So 29, you would just use a 1/4 outside your box, but you can do synthetic with it. You don't have to do long division. Okay. Find all zeros means imaginary and real, so you wouldn't be able to use your calculator as much on that one, but you could. Remember that we did those and started with synthetic division. So if you got stuck on something like 30 or 31, you can look for x-intercepts and use synthetic division to help you factor it out to the point that you can solve the rest. 32 through 35, vertical and horizontal asymptotes. Quick review of that. How do you find vertical asymptotes? Remember with those, we factor everything and then set the bottom equal to 0 for the vertical asymptotes. So if I was doing 32, you would factor the bottom into what on 32? The bottom on 32 would factor into x plus 2, x minus 2. Right? Which means I have a vertical asymptote at 2 and at -2. How do you find holes in the graph on these kind of equations? Factors that do what? Cancel out. So you wouldn't have any in 32 or 33 because there's no factors on top to cancel. You might have one on 35. How do we find horizontal asymptotes? It's that mnemonic device, Bobo Batten eats DC. Remember that one? Bigger on bottom, which is in 32. What is your horizontal asymptote for that? 0. Bigger on top, there is none. Exponents are the same. Divide your coefficients. Do you need me to do any of the other ones, 33 through 35? If I were you in 36 to find x and y intercepts, I would graph that and find them on my calculator. You don't need to do anything other than to graph that and find where they cross the axes. 36 or 37. To write that in vertex form, you can do a lot of things on that one. That's meant to complete the square. The easiest way to do 37 is either to graph the quadratic and find where the vertex is, because it's either going to be a minimum or a maximum, right? It's either the bottom of the U or the top of the U, and then just plug it in. Easier than that, to me, your multiple choice answers on this type of thing would be like this. I'm just making up random ones because I don't know what the answer is right now. What could you do with all of your multiple choice answers? Foil it out and see if it gives you the original one. That's the easiest thing to me. I know that's like a little bit more work, but sometimes it's just the easiest way. I would just foil answers till I found which one gave me that, because that would be the quickest to me. This one, I think, negative b divided by 2a. You're going to have 3 something, but 3 negative 6. So I think I was off on it. So it should be something like that. And you would just FOIL answers till you got the right one. After this is more of our exponential stuff here. 38, what happens with your ln and your e? Cancels. Better hope you get a question like that one. Answer's 2. Isn't that nice? I feel like there's something like 39. That's expanding your logs, and that's good review for our test as well. So remember, first things first on this one, what do we separate division into? Subtraction. So I would start with the ln of x minus the ln of the bottom. At the same time, how can you write a square root as an exponent? 1/2. And then what would be our last step to expanding that one? What do you do with your 1/2? Bring it to the front. Oops, meant to circle that. So my final answer for that one would look like this. Solving exponentials, solving logs, that type of thing. 40, 41, that's similar to what we did on our quiz last class. So remember for 40, what would you have to get rid of first in 40? Divide both sides by 3. And then where do we go from here to get rid of the ln? Switch it into exponential form. ln is log base what? E. So that switches into e to the 10/3 is equal to 5x. How would you then get x by itself? Divide by 5. Most likely they will have decimal answers for that, I would guess, but I don't know. So I would just type that into my calculator then. I don't think I need to go over absolute value in 42. 43, what are they asking you to do? Take f of x and g of x and do what with them? Subtract. All you have to be careful of on questions like 43 is that you don't do something stupid, like don't subtract both terms. Make sure you're subtracting the 13x and the 19. If you need to use parentheses, use parentheses. But that's the easiest place to go wrong on those questions. Those are not difficult questions, but people make silly mistakes, and I can guarantee they're going to have the silly mistake answers. So I would distribute the negative there. 5x minus 13x is negative 8x. Negative 7 minus 19 is negative 26. $45, they will give you a formula for these. All you need to know is whether it's the PE to the RT or the other interest one. So they will give you formulas for those. They'll give you, let me scroll down and I'll write it down for you. The 2 will be which is the compounded anytime but continuously formula, and this one. So they will give you both of those. You just need to know how to use them. I feel like there was a question like 47 or 48, which is really nice. Write those in logarithmic or exponential form. Should be super easy. 49. You can write a polynomial with a 0 at 0 and 3i. You can also just solve the answers till you find the one that has those zeros, which would be easy-ish. Remember, a 0 at 0 is a factor of x. A 0 at 3i is a factor of x minus 3i. And if 3i is an answer, what else is an answer? Negative 3i, which would look like x plus 3i. To get your answer, you would just have to FOIL that back together. Yes, that's involving FOILing i's. Lovely, isn't it? Ooh, 50. I remember there being an inverse question, and no one can remember how to do those because it's like from September. How do you find inverses? Anyone remember the basic starting? Switch your x and your y. Okay, because these are easy questions, but if you don't remember how to do it, you're kind of stuck. Switch your x and your y like that, and then solve for y. How do I get y by itself? Subtract 4. And then divide everything by 2. So that's 1/2 x minus 2. That's your inverse. 51 is the opposite in condensing the logs back together. And then there's systems, which we've talked about. You can solve any of those systems using matrices if you want. We've already kind of talked about that. And we talked about finding the inverse of the matrices. Whew. We kind of walked our whole way through that.